Hello and welcome to part 3 of the VisPy Realtime Data visualization tutorial. In the last part, we finished adding a connection between the Qt controls and our VisPy visuals. If we run where we left off in part 2, we have the image visual on the top, line visual on the bottom, and we're able to control the color map and the color of the line. What we're going to focus on in this video is updating the data that we're looking at. This new data could be coming from a database, it could be coming from web requests, it could be coming from an instrument or some other type of real-world thing that is pushing data to your system, or maybe you're pulling the data from some other system. Here is the diagram we left off with that represents the way our script is right now. We have our main GUI window that has the Qt controls on the left pane and the image visuals on the right side of the GUI. And we connected the color map and line color combo boxes via Qt signals to the image and line visuals to update those properties for those visuals. And what we want to do now in this video is we need to add a third object, something that represents our data source. This is that push or pull data source that I was talking about, where some kind of complex data generation is providing new data to our image, the actual 2D image array and the actual 1D line that we're visualizing. In some way, it's updating that. So let's start laying out that structure in the code, and then we'll get into some of the complexities that come along with this. So the first thing we're going to do is we're going to create a new class. We're going to call this data source. And the way we're going to update our visuals is via a Qt signal. And as mentioned in part 2, any object that emits a signal, that has a signal, needs to be a subclass of Q object. So that's why I'm subclassing it here. And signals are defined on the class level at the as part of the class instance, and then we can use them inside the class. So in this case, I'm going to make a new data signal. That's what it's called, new data. And what I pass to the PyQt signal function or class is the types of things that I'm going to return or emit from that signal. So in this case, I'm going to emit a dictionary of information, dictionary of new data. Let's go up and add the missing import for Qt core, so my IDE stops complaining. Okay, so we're going to structure this as kind of a two-part system. So we're going to make this class, and we're going to give it a limit for how long it's going to run. So we're going to say it runs for 1,000 iterations. Because it's a Qt object, we're going to give it the idea of a parent, and this is just so that we can tell Qt what parent this object might have. This is just something Qt needs to understand. We're going to keep a current count of how many iterations we've done. We're going to keep track of the number of iterations that we want. And then we're also going to keep track of the last or the current data that we've sent. So we're going to call the generate random image data function. This is what we called up above when we originally created the image. We're going to do the same thing for the line data. Oops, I'm going to call this image data. We're going to do the same thing for line data. And it's going to have num line points number of points, which is set to 200. Okay, once we have that, we're going to make a method that we can call and we will call for every iteration or every update that we want to our visuals. So what we're gonna call this run data creation. I'm gonna add an event. This is something that is very common to Qt event handlers. Anything that might be responding to some event outside or in another object. There's usually some event associated with that, and it gets passed to that callback. And I'll explain in a little bit why I'm calling this timer event once we go over GUI event loops. So we're gonna just put in some logic here to limit how many iterations this function can go. And now we actually have to update the data. So we're going to make two methods just to keep the code a little clean. One called update image data, and we'll give it whatever number of iteration we're on. Same thing for line data. We'll create a separate method for doing all of that. And then we'll update the count to tell us what iteration we're on. And lastly, we will create and emit a dictionary with our new data. So we're making up our own structure for this dictionary right now. Since we only have two values or two types of things that we want to send, we're keeping it simple and calling it image and line. And then when it comes time to actually emit the signal to let other objects know about our new data, we're going to use that new data signal that we created before. We're going to call the emit method, and we're going to pass our dictionary. So what we've done here is we've created a Qt-based object. So it's a subclass of Q object. We have a signal on this class that emits a dictionary. And then every time this method, this run data creation method, is called, it will emit a dictionary of new information that whoever is connected to that new data signal, they can use that. Let's finish this off by adding our update image and update line data methods. These methods are going to be relatively simple just because they're mimicking what a real data source might be doing. The logic or the computations that they're doing are not very CPU intensive. There's not a ton of data being moved around. The image that we're visualizing is also not very large, but I wanted to keep this simple so that we can focus on the other concepts involved here. So what we're going to do is make an image that takes the random data that we started with, so what we're doing here is we are attempting to update just a portion of the image with a single value in one column, and then the rest of the image is going to be updated random data. So we've updated the self._image data array that we're holding on to. This allows us to reduce the amount of copies and other things if we just modify this array in place. But when we want to actually send the data, we're going to be a little safe and copy this array. This way, anybody who uses the array from our emitted signal is not going to accidentally modify the value or modify the array and change the results or corrupt the results. We're going to do something similar for line data as far as not being computationally intensive. We're going to update this kind of cache of line data. And what we're doing here is we're using the NumPy roll method to kind of shift everything in our array over one. This way our display will kind of look like new data coming in on a time axis. Every time an iteration goes through, we are updating one point on the right side of our line and getting rid of the point on the most left side. And the value that we're going to put in as new data is just going to be a simple sine wave calculation. We're also going to copy this array. All right, we have some missing imports here, so let's go up and add those. Okay, let's go back down to our data source. So we've now finished out the data source as far as how we're generating data and how we're emitting the data, but now we need to actually try to connect it to the rest of our GUI application so that it is actually updating the data on our visuals. So first thing we need to do towards that effort is we need to add a method to our canvas wrapper that makes it simple to update the visuals based on this new dictionary. This is the slot or the method that our new data signal will connect to. So we're going to get a new data dictionary, and we're just going to add some prints here just to make debugging easier and just as a proof of concept here to show that things are happening. We're going to use the set data method on the image visual, and we're going to pass it the image array that we put in the dictionary's image key. Similarly for the line, I'm going to do set data, new data dict, and also give it the line. So that's all we needed for the image generation. VisPy will handle updating all of that and redrawing it, telling Qt to redraw the canvas. So that is all set. Now we need to actually connect that signal to this slot. So the way we're going to do that is by using something called a timer. Timers are available in many GUI frameworks. VisPy actually provides a wrapper around the timer so that you can use a single timer class and regardless of what GUI framework you're using. And that's what we're going to use here. So one thing we need to do now is create the data source, an instance of the data source class that we just created. And we need to connect it to our canvas wrapper. To kind of clean up some of this code, we're going to move the creation of our canvas wrapper down here in this if main block, and we're going to pass it to our main window. This will just help us control where things are connected without having to do property attribute access on other classes. Kind of a dependency injection pattern. So to make this part work, we need to update our main window so that canvas wrapper actually comes from the init arguments. Okay, simple change. So now we are passing canvas wrapper into our main window and using it here. So if we go back to the bottom here, we've created our data source, our canvas wrapper, and then our main window, which has our Qt controls inside of it. We can access that new signal that we made, that new data, by using attribute access. And then, like in part 2, where we connected to the combo box text change signal, we can do the same thing here, calling connect, and give it some slot or method that will understand what's being emitted by this signal. So in this case, this is our update method that we just added to our canvas wrapper. And then lastly, to connect this all together, we need something to call our data sources generation method. We're going to use the VisPy timer class that I mentioned and set it to trigger every 1 second. we're going to connect it to our data sources run data creation method, and we're going to tell it to start as soon as it can. And we have a missing import here. We need to import timer from VisPy. So we're going to go up to our imports. And import timer. And then let's see what happens when we run this. Oh, we have an exception here. Oh, that is a typo on my end. Line data. Let's try running this again. Another typo. Okay, one more time. Okay, so now we have updating data. You can see in the image that the random data is moving around because it's being updated. You can also notice on the left side that the left side of the image is being changed to a solid value, column by column, every iteration. In the line, we can see that the line is slowly shifting to the left, and on the right side, we have our sine wave starting. Now, while this is running, we can still change our color map. Things are still going. Things are still updating as we're doing this. Now, this works super great. This is a great use case for timers because we have a pretty simple data update method, data generation method. The problem is if our data generation takes longer or is more CPU intensive, we can run into user experience issues. So let's mimic what it would look like to have a longer running data generation. We're going to add a little sleep timer to our data generation. So right before we update the data and emit the signal, we're going to do time.sleep and let's set it for 5 seconds. So this would be like if you had to download data from some web page, run some processing on it, and then you wanted to visualize it, or maybe you were doing some kind of Ethernet TCP connection to an instrument, and that instrument only ever updated every 5 seconds, but while you were waiting for that instrument to produce the data, you were sitting, hanging, listening to that TCP connection that you had. So we've added our time.sleep. I imported it at the top, and now we're going to run this again. So if we wait 5 seconds, we'll see a small little blip of an update here. Now our timer is running every 1 second, but our generation function takes every 5 seconds. So what we can see here is that I've just clicked on this color map drop-down menu, and it's having trouble loading. You can see that it's pressed. Now it finally loaded. As I move my mouse, the highlights aren't doing anything. I just clicked blues. And if we wait and we wait, eventually it finishes. I also just closed the window and now it finally closed. This is the problem with using timers, is that all of the processing that they're doing, the callbacks that they're calling, with the way we've done it, they're all running alongside the GUI in the same series of events as the rest of the GUI. So every time our data generation runs and takes time, that's time it's taking away from the rest of the GUI events. Let's take a look at some diagrams to better explain this. So this is the diagram we had before. We've added a data source. It has some kind of data generation, and it's updating the image and line visual. We added a timer that triggers our data generation every number of iterations. But now let's look at how Qt sees the connection between these things. The way GUIs usually work is they have some type of event loop. This is a series of events that happen throughout the lifetime of the GUI application. So events like drawing the actual thing you see on the screen, dealing with key presses or mouse events or timer events. As those things happen from the operating system, from the user interacting with it, they get added to this queue of things that have to be done. And Qt, the thing managing all of this, acts as this red arrow in this diagram, and it will step through each event one by one, handling it. And we as humans, as the user, we don't typically see the delay in these events being handled. So if the Qt event loop started with a draw event, it shows you your window on your screen, you click a button, or you press a key, then it goes to handle that, then it tries to draw again, then it might handle a mouse event, and as it's handling these events, more events might be coming into this queue, so now it's going to a draw event. In our case, we had a timer, so if a timer event came up, it would be added to the bottom, and we would just keep stepping through this processing. The problem that we saw is when our timer event takes longer than it should, or longer than other events. So here we have this timer event. It's much larger than the other events. As the timer event is happening, this red arrow, this Qt event loop, it can't move on to any of the future events. We have to wait till this timer event is finished. Once it is, then we can actually move on to things, but that's why you have that that hanging of the GUI, of it not reacting. So this is something you have to be careful with when you're using timers, is you want to, by default, this is all happening in the same event loop. In future videos in the series, part 4 and 5, we'll go over ways that you can use timers or multiple threads in a event loop friendly way, so that all of the data generation and handling and all of that stuff is happening in a separate thread outside of this event loop, and we can slip in little drawing updates, little data update events instead of the long running timer events. One last thing I wanted to show is how fast these updates can happen. So if I comment out this sleep that I had in my data generation, and I can set the timer to not run every 1 second, but I can say auto. This will essentially tell the timer to push a new timer event as quickly as possible into the event loop, so that as fast as possible have Qt process new bits of data. So if we run this, we can see that our updates are happening much faster. Since I don't have that sleep, data generation is relatively fast. So that is all I have for part 3 of this video series. As I mentioned, in the next parts, we'll go over multi-threading or fancier handling of these data sources, so that we have less of an effect on the user's experience with the GUI, a more responsive GUI, possibly handling other types of data generation. Thanks for watching. Please leave any feedback you have in the comments, and I'll see you in the next video.